In this example, we are going to calculate the electric potential due to charged conducting sphere. The charge is distributed uniformly, plus Q, and we want to find the electric field due to this conducting sphere at point M, and we represent R is the distance from the point M to the center of this sphere. The sphere has a radius R0. So let's start with electric potential when the radius or the distance is bigger than the radius of the sphere. The definition of electric potential is given by V is the integral from infinity to the point M, and we represent this by R, EdL. The definition of EdL will be EdL cosine of theta. We said we come from infinity to where is the point M. The infinity, we have this dl, and this dl, we just call it a dr. Now what will be? We have the electric field direction is in opposite direction. That means that theta is the angle between dl and the electric field E. So this theta in this case, it will be 180 degrees. So it will be just E dl cosine of 180 degrees. And this it will be negative EdL. Now if we go replace this here, and we replace dr, we say dr is just dl, we just call it E dr, negative E dr. So the potential electric will be the integral from infinity R negative E dr. In this case, it will be the integral from infinity up and R down, because I replace this negative with E dr. Now the electric field, to find the electric field at this point, we use Gauss's law. For Gauss's law, we explained it in the previous videos. So to find the electric field, we use Gauss's law, and this electric field should be just Q over 4 pi epsilon 0 r squared. Now once I found the electric field, I will replace it in the integral and then calculate the electric potential. So it will be the integral from R to infinity of E, which is Q over 4 pi epsilon 0 r squared dr. And Q over 4 pi epsilon 0 are constant. They can go outside the integral, and it will be just the integral from R to infinity dr over r squared. So, and this the integral of dr over r squared will be just negative of 1 over r. Negative of 1 over r between infinity and r. So the electric potential of conducting sphere will be just Q over 4 pi epsilon 0 factor of negative 1 over r between r and infinity. This will be just Q over 4 pi epsilon 0 1 over infinity is 0, and negative 1 over r will be just plus 1 over r. It will be just Q over 4 pi epsilon 0 r. This is the electric potential at point M, and this point M is further from the sphere. We said when R is bigger than R0, the electric potential at the radius R is given by Q over 4 pi epsilon 0 R. Now, when R equals to R0, we just replace R with R0. That means the electric potential R0 equals to R. It will just Q over 4 pi epsilon 0 R0. Now, when R is less than R0, means if we are in this zone, when we want to find the electric field between 2 points, A and B, it will be the integral from RA to RB E dl. This is by definition. The electric potential difference between 2 points will be from R, which is the final position, and this is the initial position. It will be up, E dl. Now, if I want the electric potential difference between this limit of R0 and inside, I call it R. When R is less than R0, the difference of potential between R0 and R will be the integral from R0 to R E dl. So if I am inside this sphere, and this sphere is conducting sphere, there is no electric field. If there is no electric field, this term is zero. All I have, the electric potential at the limit R0 equals to VR. That means outside the sphere, the electric potential will be Q over 4 pi epsilon 0 times R. At the limit, it will be just Q over 4 pi epsilon 0 R0. If R is less than R0, the electric potential also will be Q over 4 pi epsilon 0 R0. Let's graph this function of electric potential and R. When we are at distance R that is less than R0, it will be just Q over 4 pi epsilon 0 R0 when R, the radius R, lowercase r, is less or equal to R, the electric potential is constant. If we go further, if we go outside R0, the electric potential, we said the V of R, it will be just Q over 4 pi epsilon 0 R. That means this function is inversely proportional to the distance. So this is how will be the electric potential as function of the distance. Inside the sphere, there is no electric field and electric potential is constant. Outside the sphere, the electric potential is inversely proportional to the distance. Thank you.